So this is now we use MDF just because it's simple, it's cheap, you can cut it very good, you can make a lot of tests, it's not a problem. If something goes wrong, you can adjust it, but this could be plywood or whatever, or multiplex, or it can be anything. So we make it multi-layered, and like here all the smart valves are mounted. Now it's full, but it could be as well as two smart valves. You can place them whatever. They're now all arrayed very nicely, but it can be any form, that doesn't matter at all. This is where smart valve, like you've seen the PCB board, is mounted. Like this is an old test unit, so it's mounted on top. The air is pushing inside and the valve is holding it, is closing up the whole part. If the valve opens up, then air comes through the big hole, and then you can route it to wherever you want on the board.
So if the air comes in from here, it doesn't mean it's going to come out there.
It
could come out somewhere else.
Yeah, it doesn't matter. That's why it's super easy to in Tony's software you can. I made one in the form of an eye, so round with different layers, and if you see on top of it.
Is that the one you bought?
In London,
yes.
We call it the eye, and just to experiment, you know. But you can place pipes however you want, and this can still look like this, or they can follow the form. It doesn't matter, and it's a matter of placing them on the computer, export. Bam, you get the layers.
So basically, if correct me if I'm wrong, but you could have a larger pipe here that needs more air, and then you could just basically send 2 or 3 of those.
They work together to one.
To one location, right, for the pipe.
Or you can, if it's not foreseen in the design and the air channels are not going together, you could still say I make an extra plate to cover those 4 holes. And then in the software, I say that those 4 holes are working together, and then you will have, let's say, 4 smart valves, and one of them is the master, and all the other are slaves, and they just listen to what this one is doing. But then the smart valve has a pressure sensor, and it's inside of this hole, and it's closing it off. So inside this hole there's a pressure sensor, and when the valve opens up, it measures as well how much pressure is going inside the pipe, and at the same time it's measuring inside this little canal, which comes out up here, and here it measures the air outside, and it's comparing the pressure inside the pipe with the air inside the room. I think it's 9,000 times a second, and for each time it makes 8 samples. So it's crazy. That's why the signal is so perfect. And all these sensing canals are connected together, and that's why we now have like a production stop, because Tony realized, like, fuck, how are we gonna calibrate all these sensors of 1,000 pipes to the same basic level, the 0.0 of each. What pressure is 0, because every sensor is slightly different, of course, because it's a physical thing. And that's why now we have 2 extra parts. One is a monitor smart valve, and it's just only to monitor and to monitor everything. And then there is a second monitor valve which allows pressure into the sensing canal, and then he could say, like, okay, we fill the sensing canal up to 100 millimeters of pressure, then we stop, and then we say to all smart valves in 1 second, this is 100.
Right.
So imagine calibrating pipe for each pipe individual, and just go like done.
Wow. Yeah.
And that's why
whole ranks of pipes
for 10,000 of pipes. That's why it's like, okay, we need to build this in now, test it before we go on.